Okay, we are looking at an assignment that's reviewing radicals and exponents on the front and then a big review on the back. This is very much what's going to be on your upcoming test. So let's see how you're doing on these concepts. Starting with row number 1, the directions only say to rewrite each example, each expression. So we don't have to do any simplifying. So we're just using the exponent and index rule. So what is that rule again? Let's write it up at the top. If you have some number n as your index and you have some exponent m, then we know that we can rewrite this as a fractional exponent where your big base stays the same, whether it's a variable or a number, and then the n and the m, what becomes the numerator and what becomes the denominator? You got it. Okay, let's go apply this to 1a. So the big base of 2, what's going to go where? Okay, you got it. How'd you do? Next one, big base of x, what's going to go where? You got it. Anything to the power of 1/2 can just be rewritten as the square root. Sure, I could put the 2 and the 1 in, but I don't have to. I could put the 2 and the 1 in or just leave it. It's up to you. Last one, 7th root of 4 to the 6th. So because this just says to rewrite it, I'm done. I don't have to do any further simplifying. Look at the directions for the next one. Also just want a rewrite. Big base of 50, power of invisible 1 over 3. So this is going backwards from that top row. Big base of 5. What's going to become the numerator and the denominator in your fractional exponent? You got it, 11/7. Big base of 70. What's going to become your numerator and your denominator? Look to see how you did. Big base of 2. You got it, power of 9/5. Okay. So when it says rewrite, we're done. Now, we get to this next section. It says to simplify without a calculator. So using that fluorescent green sheet could be helpful. I'm going to show you the 2 different ways here. First, if you want to rewrite this as cubed root of 8 to the 5th, that's using the row 1 steps. Cubed root of 8 times 8 times 8, there's a group of 3, but there's still 2 8s left over. So an 8 can come out, but let's simplify this even further. Can't 8 become 2 times 2 times 2? And the other 8 becomes 2 times 2 times 2. So group of 3, an 8 comes out. Group of 3, a 2 comes out. Group of 3, another 2 comes out. What are these 3 numbers doing? They're factors, they're multiplying. 8 times 2 is 16. 16 times 2 is 32. My final answer for 3A is 32. That's Tia's method. Let's go try Tehani's. Tehani rewrites the 8 as 2 to the 3rd using your fluorescent green sheet. Now we put the power of 5/3. What is 3 times 5/3? Well, it's just 5. 2 to the 5th is just 32. Which way did you like better to get the 32? You get to choose whether you do Tia or Tehani's way. So pause the video right now, try the next one, and then let's see how you did. 625 is 5 to the 4th, using that green sheet, times the 3/2 power. That becomes 5 to the 12/2. 4 times 3 is 12 over 2. And final answer is just 5 to the 6th power. If you want to keep reducing that, you can, but you don't need to when it's that big of a number. Last, 64 can be rewritten as 4 to the 3rd. The 3's cross out. 4 squared is just 16. All right, we're now on the next one that says simplify again. On the 3, third root, index of 3, it means we're going to be looking for groups of 3, and we've got a negative under there. So 343, what times what makes 343? I want you to try your green sheet multiplying that out and see. You got it. It's a 7. So could it be -7 times -7 times -7 with that -1 out there? And that's your final answer. So group of 3, a -7 comes out. There's your answer. The next one could be broken down. If I convert this into a fractional exponent, x to the 21/7 just becomes x to the 3rd. So I just used Tehani's method on that. How'd you do? Doing the same thing to the next one. This is going to become the 4th root of the numerator over the 4th root of the denominator. And that becomes x to the 8/4. And then could I rewrite 16 as 4 squared or 2 to the 4th to the 1/4 power? The point being that this bottom is just going to end up as x squared over 2. So some people look at the bottom as the 4th root of, and then they break it up. Well, there's my group of 4. A 2 comes out. Okay, I want to try that one again. I feel like people are going to be confused. Let me try this one more time. I want you to erase your page, pause the video, and start again. Okay, numerator, x to the 8/4. Denominator, 16 to the 1/4. Top just becomes x squared. Bottom, I need to figure this one out. 16 to the 1/4. Could I rewrite 16 in any other fashion? Yes, 2 to the 4th. So the 4's cross out, and it just leaves me 2 to the 1st. Or 2. Square root of 40, 4 times 10, 2 times 2 times 2 times 5. A 2 comes out, 10 stays underneath. Don't forget the plus or minus. Cubed root of 54, 6 and 9. 2 times 3 times 3 times 3. A 3 comes out. A cubed root of 2 stays in. 5th root of 64. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it's really 2 to the 6th. So group of 5, a 2 comes out. 5th root of 2, there's 1 left underneath. Square root of c to the 7th, d to the 9th. C to the 7 halves, d to the 9 halves. You could rewrite this and do Tehani's way, but I like Tia's way. Groups of 2, a c comes out, another c, another c. So there's c to the 3rd out front, d to the 3rd out front, and square root of this leftover c is all that's left over that's not used. Final answer. All right, next one, 8th root of p to the 5th, q to the 19th. Let's count and make sure I have 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19. Okay, groups of 8. Do I even have 8 of these? Nope. So I can't take anything out for the p's. 1, 2, 3, 4, 5, 6, 7, 8 q's. So a q comes out. 1, 2, 4, 5, 6, 7, 8 more q's. Another q comes out. Leaves me q to the third inside. So final answer is just going to be q squared outside. And then 8th root of p to the 5th, q to the third, left underneath. Okay, cubed root of y to the 20th. Over cubed root of z to the 12th. We're looking for groups of 3. So 3 y's, a y comes out, another y, another y, another y, another y, another y, and there's 2 left over. So 1, 2, 3, 4, 5, 6. And then down here, a z, a z, a z, a z, z to the 4th comes out. What's the only thing left over? These little y squareds right here that didn't get used up. So final answer, y to the 6th, z to the 4th, cubed root of y squared. All right, this guy right here, using the add rule, becomes 5 to the x plus 7. This guy right here, 216 is 6 to the 3rd. And then don't forget to the power of x over 6. And then we could use the subtract rule. And finally, 81 could be rewritten as 3 to the 4th. And then 1/3 could be rewritten as 3 to the negative 1. Don't forget the x. And so add rule. Now, these bottom ones, writing as an equivalent expression, these bottom ones are not on the upcoming test. They're just kind of a higher level. See if you can rewrite the expression in a different way. Okay, so these bottom ones right here, numbers 5, A, B, and C are not on the test. Everything else above is.